Agentic AI didn't arrive overnight. It climbed a ladder, 7 rungs, and every single rung added exactly one capability the rung below it was missing. At the bottom, script bots with no brain at all. At the top, teams of agents that delegate to each other. Each rung added exactly one capability the rung below it lacked. Let's climb it from the very bottom, one rung at a time. We start at the very bottom. Script bots have zero intelligence, they're just rules. A query comes in as a raw string. It gets matched against a block of hard-coded scripts. Regex, a keyword map, and a Fels tree, and that's the whole brain, a rulebook. A matching, pre-written canned answer goes out. There's no understanding and no flexibility. If your input doesn't match a rule, the bot simply breaks. This is where chatbots and phone trees lived for decades. The one thing this rung adds is rules. Now we add real intelligence. The large language model replaces the rulebook. Ask it a question in plain language. First, the tokenizer splits your text into tokens the model can actually process. Then, those tokens run through an attention-based neural network, the transformer. Here, self-attention weighs how every token relates to the others to build context. This is the engine of understanding. A decoder then generates the answer, one token at a time, autoregressively, and out comes a brand new answer it has never seen before. It genuinely understands and generates language. A massive leap. But notice what's missing. No tools, no live data, and no memory. Everything it knows is frozen into its training weights. Ask it today's weather, and it can't help. The new capability here is intelligence. Here, the model stops being trapped in its own head. It gains function calling. When the query needs something the model doesn't know, the LLM decides whether and which tool to call. It sends a structured call out over that tool's API. A weather service, a search engine, a code runner, gets the result back and folds it into the answer. It can finally reach the outside world, but look at that dashed line. Every tool needs its own custom, unique API wiring. The final answer comes back grounded in real tool results. This is the first step from talker to doer. The catch is that custom wiring per tool doesn't scale cleanly. And we'll fix exactly that at level 6 with MCP. The new capability here is reach. RAG solves the model's biggest weakness, outdated, made-up knowledge. The trick is right there in the name, and it's 3 steps. First, you connect a knowledge source. A vector database, your documents, the live web. Retrieve. Take the query and pull the most relevant chunks from those sources by similarity search. Augment. Inject those retrieved chunks as context into the prompt, alongside the system prompt. Generate. Now the LLM produces its answer from that augmented prompt, not from frozen memory, but from the context you just handed it. Out comes a fact-grounded response with traceable sources. The model isn't guessing from frozen memory anymore. It's answering from your actual data, and that's how you stop hallucinations. The new capability is grounding. Until now, every conversation started from 0. Agentic memory changes that. The agent sits between the query and the output, and before it acts, it reads from a memory store. That memory is a read-write store the agent consults every turn, and it splits 2 ways, just like human memory. Short-term, a fast cache of recent context, and a working scratchpad for the current task. Long-term splits 3 ways: semantic memory for durable facts, episodic memory for past events and conversations, and procedural memory for learned skills and routines. It reads before acting, then writes new learnings back after. The output now reflects everything it has accumulated about you. It carries context across turns and even across sessions. A stateless responder becomes something that remembers who you are and what you did last time. The new capability is memory. Remember the custom API problem from level 3? Every tool needing its own hand-built wiring. The model context protocol fixes it. The agent reasons about the request and decides it needs an external capability. Instead of integrating each tool by hand, it speaks one standard protocol to an MCP server. A single, consistent contract for everything. That server exposes any number of tools behind the same interface. Browser automation with Playwright, vector search with Chroma, your internal systems. Add a server, and the agent can use it instantly, with no new integration code. The tool result returns through MCP and folds straight into the answer. This is the USB-C for AI tools moment, and it's what makes enterprise-grade agents actually practical. The new capability is standardized access. At the very top, agents that work as a team. One agent can't be expert at everything, so the main agent acts like a manager. It takes the high-level goal, plans, and breaks it into subtasks. It delegates a piece to a specialist subagent over the A2A protocol, a standard channel for passing tasks and returning results. Each subagent has its own tools and its own memory, does its part, and reports back. The main agent loops over as many specialists as it needs, integrates everything, and returns the final assembled result. This is multi-agent collaboration, not one smart model, but a coordinated system of agents. The new capability is collaboration, and this is where we are right now. So here's the whole climb on one screen. 7 rungs, and each one added exactly one capability. Script bots gave us rules, large language models added intelligence, tools gave the model reach. RAG added grounding in real data. Agentic Memory gave it memory across time. MCP gave us standardized access to any tool, and A2A gave us collaboration between agents. Stack all 7, rules, intelligence, reach, grounding, memory, standard access, and collaboration, and you get the agentic systems we're building today. That's the ladder.